Welcome to the lesson about microcontroller models for smart textiles. In this lesson, we will learn something about the microcontroller which are adapted for smart textile applications. And at the end of this lesson, you will see some study cases for having a detailed idea about the microcontroller. In the most cases, an e-textile product has always a control subsystem. Microcontrollers are often used for low power systems because of their low energy consumption, even if their processing power is limited. So, how to choose a suitable microcontroller for your project? There are several criteria which should be considered. First of all, the power source is important for a microcontroller. The range of operating voltage decides the choice of power source. The possibility of regulated power supply by the microcontroller is important as well. That decides what kind of sensors or actuators can be connected to the microcontroller. The second criterion is the input and output pin. How many sensors or actuators can be connected to the microcontroller? Is there analog input pin for the sensors? Is there possible to send a numerical information to the actor via an PWM output? Is it possible to use the SPI or I2C buses for data transmission? All these criteria decides the extendability of the microcontroller and the choice of sensors and actors. The third criteria is the clock speed of microcontroller. This criterion is sometimes ignored by the developer, but some sensors or actuators have the special requirements for the clock speed. For the smart textile project, the compatibility with textile structure is another important criterion for the choice of microcontroller. Nowadays, there are several commercial products in the market, which are called sewable microcontroller. As for these kinds of microcontroller, they have a round shape which allows them to avoid to damage the textile fabric. Their connection pins are hole shape, which makes them compatible for the sew process by the needle. Of course, besides of the previous criteria, there are some others, such as the size, the price, the weight, the size of memory, etc. From this table, you can find some commercial sewable control boards which are available in the market. The most popular board is a LilyPad and Adafruit Flora. They are powerful for the DIY smart textile project. Many compatible accessories such as strip LED, light sensor, accelerometer, Bluetooth, and Zigbee connector. As for the coding, microcontrollers are typically programmed in high-level language such as C++ or Java. However, in the last decade, the most used code for smart textile project is Arduino code. From this slide, you can see the interface of an Arduino IDE. This is an example of a simple Arduino program that makes a LED blink on and off at a frequency of 1 Hz. The code can be split into 3 different sections. The first section is variable declaration section. In this section, all the global variables are declared and they can be called in any section that follow. The second section is called setup section. In this section, the user defines which pins are inputs or outputs. Sometimes the configuration of control board is done in this section, such as the initialization of serial port and the parameters of control board. The last section is called loop section, which is where the function of the microcontroller is written. Any actions that require reading or writing values from pins or computing the values of different variables is done here, and this section will loop consecutively. You can see a smart textile sample from this slide. This sample is about the textile display. The display fabric are controlled by a microcontroller. This microcontroller is Arduino Micro board. It is soldered on a FR4 printed circuit board. This design of electronic part is not a good solution for the textile structure because the rigid PCB will influence the comfort of wearing and the size of PCB is very big as well. In this slide, you see the second sample of smart textile. In this sample, a Adafruit Flora control board is sewing on a woven fabric. With the hole shape pin, the microcontroller can be easily integrated into textile structures by sewing technology. The small size and the round shape of control board make the microcontroller compatible with textile structures. The final example of smart textile is using flexible printed circuit board. On this flexible PCB, there is a microcontroller assembly. With the SPI and I2C buses, this microcontroller connects with ECG electrodes and an accelerometer. The flexible PCB makes it easier to integrate into textile texture. In this lesson, we have presented some microcontroller and give you some advices about how to choose a compatible one for your smart textile project. Besides of the control board, there is another huge problem in the smart textile, which is how to connect your components with textile structure. In the next lesson, we will talk about the textile connectors. See you in the next lesson.